So today we're going to talk about universal sets and Venn diagrams. So briefly, a universal set is, just think about it as any kind of set that contains every single element. Okay, it's kind of like a collection of objects. It doesn't matter how big or small the set is. It's a universal set is just however many elements make up that entire set. Okay. So you'll see this terminology a lot, and we use the symbol U to represent universal. Okay, so a complement, remember we talked about complements, is relative to a universal set. Remember the notation? I like to use the little lowercase c as a superscript. So A superscript C, right, contains all the elements in the universal set, but are not in that set A. So the complement of A, okay, we'll let A be a set. We're going to say, okay, what's the complement of A? Okay, this is the notation I'm talking about right here. It contains all the elements in that universal set, but are not in set A. So picture's worth 1,000 words, right? So we have like this orange rectangle, and we'll call that A. I will call that a universal set, which is this U here, okay? And within that set, we have a collection of numbers, and then we have a smaller set, okay, in green, and then we'll call that set A. And set A contains 1, 2, 3. 1, 2, 4. I'm sorry, 1, 2, 4. Okay, so again, set A has these elements 1, 2, 4 in green. Okay, and the universal set is basically everything in that entire collection. Okay, which is basically going to be 1 to 9, right? So the little subset, is going to be 1, 2, and 4. That's in green. I want to know what is the complement of A. Again, we want to do that by identifying all of the elements that are basically, how do I want to word this? That are basically all of the elements that are in the universal set, but they're not in set A. Well, if you clearly look at that, okay, the elements that are not in the universal set will be these numbers. Will be 3, 5, 6, 7, 8, and 9. All right. So all of those elements, okay, all those elements are not in set A, but they're in the universal set, but they're just not in set A, right? 3, 5, 6, 7, 8, 9 are not part of set A in green, all right? So that's what we mean when we have a complement, okay? We want to make sure that all the elements, the complement of A contains all the elements in the universal set, but are not in set A. And that is the notation you would write down. A superscript C equals, and then in braces, 3, 5, 6, 7, 8, 9. Okay? So just to kind of recap of what that meant. The next thing I want to talk about is, remember we talked about unions and intersections? I want to go back on that. I want to show you a picture. Okay? So We'll talk about Venn diagrams very briefly, okay? Right, so here we have two sets, okay? So I'm going to do this one. And I'm going to do this one. Right? And we'll call this left circle A, that'll be set A, and the right one will be set B. So if we want to find if you want to find, let me see. So what does this mean? Remember that notation with the U? Okay. If you recall from a little bit the previous lesson, that U is a union, okay? What does the union mean, okay? So the union of A and B contains all elements in either set. So, all right, so let me write that down for you. Okay, so this is going to be the union. Because you have the U, all right? And what that means is that union contains all elements in either set. Okay? All right, so what that really means is that an element could be in either set, could be in A or it could be in B, okay? And we usually indicate that, if you want to be technical here, we kind of do this. Whoops, let me make sure I'm not erasing. I almost hit the eraser button. I'm going to sort of highlight where these elements will be located, okay? So just kind of bear with me. All right, so that's what we're going to be here. In other words, I'm outlining the sets. I'm doing that because an element could be in set A or set B. It's not restricted. It could be in either set, okay? The next thing that we want to do is the intersection, which is the upside down U. Okay, this is the intersection. And the intersection is the easiest to understand because it basically means that the elements will share commonality in both sets A and both sets B. Okay, in other words, they're going to be in both sets. Okay, so basically, this is the intersection, and it's going to be elements in both sets. And you'll see that. You'll see what I mean when I draw the Venn diagram, okay? So, again, oops. Let's try to do a little better picture here. All right, and then we'll do another one. And again, this will be set A, and this will be set B, all right? So, I want you to find the intersection, okay? Well, elements that are in both sets A and B can only be here. They can only share common ground here. Does that make sense? So all the elements that you will find in this shaded red area means that they will exist in both sets. Okay, does that make sense? Okay, so both sets, okay? In other words, let's say you had, some numbers, okay? Let's say you had, 1, 3, 4, 5. Okay, so you have some numbers. You got numbers, 1, 3, 5 in set A, and then you got 4, 5, 3 in set B. Well, you notice that 3 and 5 are in both of those sets. 3 is in both set A and B. 5 are in both sets A and B. So those two elements are in both sets. So the union would be 3 and 5 in the red region, okay? Because you want elements that are in both sets, not just one or the other. Does that make sense? Okay, so that's what the intersection means, all right? And then the next thing we talk about is complement. I think we talked about complement, right? You remember that notation? So why don't we just say, we'll just call the first set A, and we want to find the complement of A, all right? So again, what does that mean? It means we'll contain all elements, right? All elements not in the set A. Okay? So complement of A, and then we want to find the complement of A, the intersection of the complement of A and B. And that will contain the elements in set B that are not, notice the key word, not in set A. I know the notation and the wording can be a little overwhelming. I totally understand that. Sometimes I even have to think and say, okay, wait a minute, what is this? And then gather my thoughts and then process it. But I think the Venn diagrams is an excellent way of visually representing what's going on. Okay, so you have two sets, again, A and B, and then we want to find, the intersection of the complement A and B. Okay, well, if you want to show where these elements are going to be located, we got to look at the statement that we just read, right? The intersection of complement A and B, again, these elements will contain the elements in set B that are not in set A. So if they're in set B, then they have to be here. I'm just going to highlight. I'm not going to color the whole circle in, but if they're in set B, then they cannot be in set A. So that means that it has to not be in set A. Because if I overlap it, that means I'm in A. I don't want to be in A. The complement clearly states that all elements not in set A. Okay? So In this particular example we have over here, all right, we want to find the intersection of the complement A and B. Well, that means that, the complement of A means all elements not in set A. And then we want to find the intersection of set B. Well, go back to that first statement. We should be shading in all of B, and we should not be entering in set A. That's why I kind of did this moon shape, all right? That's what it would look like, okay? So you would list whatever elements in B, and you would just list them, okay? Because you don't want to list anything in A or the union, which you don't want that, okay? You don't want nothing in A. So that's why this is a really good representation of what it looks like visually, rather than just having a bunch of numbers and objects, and then you can, have a hard time seeing it. So we'll just keep it very visual, and you can see that all the elements will be in B, but not in set A, okay? So these are some really good visual examples of Venn diagrams. Now they can get more complicated, but I don't want to do that. I just wanted to show you the basic ones so that you see more often. Thank you so much for watching my video.